Hi all, and welcome to today's session of Virtually Golden presented by Golden United. My name's Annie, and I'm here to make sure that we have all of our technical stuff in order. So just a little technical housekeeping today. We have Jim Ranville speaking, and if you have any questions at all, be sure to just use the mute and unmute button, which is in the bottom left-hand corner of your screen. You can also use the chat function if you prefer to input questions and make comments throughout the presentation. The presentation is also being recorded, so if you happen to miss part of it or if you want to share it with any of your friends or family, you can do that easily as well. It'll be linked on the goldenunited.org homepage. We have a YouTube channel where all of our Virtually Golden presentations are available to watch. With that, I'm going to hand it over to Kathy Smith, who is spearheading the Virtually Golden Lunch and Learn series.
Thank you, Annie. We have Jim Ranville with us today. Jim's a professor at Mines, and he's going to be telling us about recreational impacts on Clear Creek water chemistry. Jim is originally a Michigander, and he obtained a BS in chemistry at Lake Superior State University. He came to Mines to pursue graduate studies, obtained a MS and a PhD in geochemistry. He then spent 2.5 years performing postdoc work at Monash University in Melbourne, Australia. And then he returned to Mines to take a position as a research assistant professor. He's now a full professor in the Department of Chemistry. Much of Jim's research at Mines involves developing methods to collect and analyze very, very tiny particles that he'll tell us about from rivers, reservoirs, mountain streams, soil solutions, and groundwaters. Take it away, Jim.
Thanks, Kathy. Thanks for that introduction. And I want to personally thank everyone for this opportunity to spend another 30 minutes on Zoom today. I don't know what I would have done from 12 to 12:30 without a Zoom meeting. Kathy invited me to present sort of a case study. I'm not going to do a broad presentation on all the various impacts on Clear Creek, but just a couple studies that we've been involved with. Kathy's a great part of my research group. She attends most of my research group meetings with my grad students, and she's providing us with her expertise obtained over a few years of research. In fact, I might mention that Kathy and I first started working together in 1988 in a project up near Leadville. And so I was doing work on, funny thing, small particles in rivers. And so 3 decades later, I'm talking to everyone about small particles in rivers. We're going to talk a little bit about something a little more close to home than Leadville. So again, this will be just a couple case studies and not an in-depth review of Clear Creek. Everyone who lives in Golden probably is certainly familiar with the Clear Creek watershed. It starts up near Loveland Pass, and when you're driving up I-70, most of your trip to the mountains, you're following Clear Creek. Of course, it's the center of Golden, center of a lot of recreational activities in the summer, which we're going to talk about. Of course, it's also a supply to places like Stanley Lake, and eventually it does enter the South Platte on the north side of Denver. Some of these facts you guys probably already know. It's about 500, 600 square miles in this drainage, and most of it's mountainous. So most of our water is coming from what we think about Colorado, pristine mountain streams. We see the typical flow over the course of the year. This is the last year from May 2019 to now. And again, everyone who lives in Golden knows that this is the time you're rafting, and maybe down here when the flow drops a little bit, this is the time when you're wading and playing in the stream. So when we were looking at the flow, which is in cubic feet per second versus time, the kinds of studies we want to do, it's kind of hard to do during the high flow times. So the recreational samples we took from Clear Creek were taken over several Labor Day weekends in order to see when there's a lot of activity in the stream, but also to try to be down where there's a little bit less flow. There's a number of things going on throughout the Clear Creek watershed. If you go upstream, you'll note that there's a lot of historical mining activities. So these abandoned mine sites, which some are being actively treated. If we have time, I was going to talk a little bit about this. This is a non-recreational impact to Clear Creek, but I thought it might be of interest. Of course, we do have the rafting upstream. And the topic of today's discussion is the activities that are going on in downtown Golden. Anyone who's walked the stream on a busy summer weekend know there's a bit of stress being put on the river. And of course, eventually Clear Creek enters the South Platte in Denver. And so there's no shortage of things to study. And maybe I'll just show a quick example of these two other studies if we have time. So what I'm going to focus on, again, this is not an exhaustive study of all the issues with Clear Creek, but one issue we were interested in was in sunscreens. And a little bit later on, I'll tell you, you'll see why we're interested in sunscreens. The study I'm going to talk about didn't really start out with the idea of this being a particular chemical of concern, but it was related to our bigger studies on fine particles. And so just as an introduction, there are two kinds of sunscreens. There are the mineral sunscreens, which essentially block the light and just prevent the light from interacting with your skin. The chemical sunscreens absorb the UV, protecting you from the UV rays and just sort of generate some heat. And so these two broad classes have a whole lot of subcategories of what chemicals are used in each of these two types of sunscreens. So when you assess chemicals, it's always a weighing of benefits and risks. Certainly, I think everything in life has that equation going on in your head. For the sunscreen example, you can look for various sources. I have a quote here from the Skin Cancer Foundation that just, if you start using sunscreens, you can reduce your chance of cancer by a significant percentage, both carcinoma and melanoma. So there's an obvious benefit. The question about risk oftentimes is a lot harder to identify. As far as we're concerned as humans, there are reports by the FDA that these chemicals, some of these that are used in the sunscreens, are absorbed by the body, but there's still a lot of work to be done to determine whether there are real health effects. A little bit more of my concern is what about the environment? And sunscreens have been definitely linked to coral bleaching in the marine environment, but there's little or nothing known about potential impacts in freshwaters. Now, this is a cartoon that's taken from one of the NGOs, and it lists at least their idea of toxicity ratings. Again, words like toxicity and risk are very politically charged words, so you have to be careful whether you really have the data to make a statement like this. But if we take this as an assessment, the idea is that some of these chemical sunscreens seem to have higher potential for risk than some of the mineral sunscreens, the two of which are most common are titanium dioxide and zinc oxide. And we'll talk a little bit more about that. So the question was, if I go back a slide, if these folks are doing what they should be doing, which is protecting themselves from the Colorado sun, are any of these chemicals being used, and do we see them entering the environment? So I circled oxybenzone here. It's one of the chemicals we looked at. So how do we study this? Well, in any situation, we're interested in downtown Golden, where if you hit the trail at 8 a.m., you pretty much have it by yourself, and then by mid-afternoon, you have a lot of company. And so we are curious about the sunscreen chemicals in Golden. So as often one does in a study, you try to compare it to something else. So we had a sampling site. We call this the upstream site, and this the downstream site. Turns out in later studies, we went even further upstream because the data I'll show you, this wasn't This may have been upstream, but it wasn't totally devoid of people using the stream. So what do you think we're going to see if we look at the situation where we have no people and people? What we looked at or saw was there's a day-night cycle of sunscreen in downtown Golden. So if I show this graph, this is one of the chemicals was listed fairly high on that toxicity scale. And we looked at it over a course of 3 days. So over the Labor Day weekend, this is from 2017. We did this study 3 years now. 2015 is this data. 2017 and 2019 I won't show today, I don't think. So what does this mean? So this is our time axis. So 9 in the morning to 5 in the afternoon, 1700 hours. And the scale here is how much oxybenzone we found in the water. And it's given in units of nanograms per liter. And what does that unit mean? Well, to kind of put it in perspective, think about other things that we'd find in the water. For example, hardness. Calcium and magnesium are the constituents that are present in water that give us either hard or soft water. In Golden, the hardness is probably somewhere on the order of 20 or 30 milligrams per liter. So if we think of the hardness cations as being milligrams per liter, if we think about scales of 1,000, we have milligrams to micrograms to nanograms. So although the oxybenzone present it's like 1,000 to 10,000 times less concentrated than, say, again, those hardness cations, just to put it in perspective. But what I want to really show is that when you sample upstream, and DL means detection limit, so we really don't know too much below this line. So there's different ways of representing this data. On this slide, we just represented as 0. I really don't know where these numbers are between 0 and this line. But let's just go with the flow here, no pun intended, and say that we basically almost never see any of the sunscreen chemical upstream. I mentioned before, we don't think we're quite to what we would call background because we did observe people going into the stream further up. That site is located near the 6th Avenue bridge, and so there was some activity. But the major thing to note is that when people aren't in the river, there is no oxybenzone. And we see this repeatable spike every afternoon for 3 days in a row over the Labor Day weekend. Again, the Labor Day weekend was chosen for a couple reasons. One, the flow is lower, and it's kind of like the last hurrah before people are ready to go back to work and school. So there's quite a bit of activity. In recent studies, we extended our sampling further and further out into the week, and we never saw anything as far as oxybenzone on the Tuesday or Wednesday or Thursday following the Labor Day weekend. So this is a clear signal of human activities. And so we are indeed putting oxybenzone into the water. So I guess the good news is that some people are using sunscreen. We're not alone. In 1 year, in 2017, we just decided to look at some other recreational rivers. We have some colleagues in Phoenix, Arizona. The Salt River is quite a bit larger in terms of flow than Clear Creek, but there's still a lot of this inner tubing, rafting type activity on the Salt River. Truckee River is in Reno, Nevada. It's in many ways a lot like Clear Creek, maybe a little bit bigger flow, I think. But one thing we did notice is that it's a little bit different. It's more of an engineered stream. A lot of the bed of the river there is concrete, and that had some implications later on that I don't really talk about. But for the purpose of this, here's our oxybenzone scale again in that nanograms per liter unit. And here's our sampling, and we didn't take as many time points. We just took a morning sample and an afternoon sample. And what you can see is the same kind of story, morning, 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 and then after the weekend, we really don't see anything, so we were below detection. But congratulations, Golden. We have the highest sunscreen on this particular date, and then Salt River less, and the Truckee River just a little bit. Salt River was a little bit higher than us on the Monday. What we did notice also is if you count the number of bathers and try to plot, how much oxybenzene is in the water. This is a term called load. It's simply the concentration times the discharge, how much water is moving. So it gives you mass per time. What we see is that related to the number of bathers, we're seeing more oxybenzone in Arizona. So that might not be too surprising given the conditions in Arizona, that it would appear that people are using more sunscreen there, and we're about the same as the folks in Nevada. So you can kind of relate this kind of relationship back to, how many people were in the river at these different times. What about nano sunscreens? These mineral sunscreens that are recommended by many people. And this is not a product recommendation on my part, but you would find a number of sources suggesting these might be better. Some of us might remember that this is what zinc oxide containing sunscreen looks like when the particles are big. Zinc is essentially like a pigment, like you might have in paint. Usually it's titanium dioxide, but zinc oxide also gives you this nice white color. Well, most of us don't like to paint our face before we go out. And so on this side is something called nano zinc oxide. And I'll talk about nano in a little bit. But part of the issue is if you make the particles small enough, they pretty much become invisible. So people are more comfortable walking around looking like this than this. Not everybody agrees that this nanotechnology is a good thing, and there's a number of places out there that say how and why you should avoid the nano sunscreens. And so there's still a little controversy there. But this brings me around to this idea of what is nano and why was I studying sunscreen in Clear Creek to begin with? As Kathy mentioned, a lot of my work has been aimed towards detecting small particles in the environment and developing methods to do that and then apply it in different worlds. And another way of saying fine particle is nanoparticle. And it's based on this scale, which we have from 10 centimeters in units of 10, going from centimeters to millimeters to microns to nanometers. And so if we start out with a familiar scale, on the centimeter scale, we have a tennis ball. As we go progressively smaller, we have things like physical objects that might be familiar, the width of a hair, biological cells, in this case, blood cells. Unfortunately, we have these critters around 100 nanometers or so, and then we have molecules. So the scale is not a linear scale, it's a scale of tens. The scale here goes the other way and say, well, what's the relative scale of things? Well, a tennis ball to the moon is about the same as the tennis ball to these molecules. And so to put that in kind of general perspective, where we talk about nanomaterials are things, they're somewhat operationally defined as things less than 100 nanometers. So think of again, sadly, your COVID virus and smaller. If I go back a second, that's part of why, again, we said that if this is the exact same material, this is big pieces of zinc oxide, and these are these nanomaterials. So they interact with light differently. And so really the sunscreen project was just a small part of what I and my students work on in terms of understanding if we create nanotechnology, we put small particles into different things, what are happening to those in the environment? Because certainly the driving force is you can make a lot of money building nano-enabled materials. There are tremendous benefits from these materials, which I don't have time to talk about, in all range of applications. But the question becomes is if we use it, will it enter the environment? So from production of the materials to putting these little particles into various things, say for example, that sunscreen, what we're really talking about with Clear Creek and Golden is the use phase. Are any of those nanoparticles of zinc or titanium getting into our soil, water, or sediments? Well, let's go back. Let's go back to Golden. And you saw on the top that we could see that definitely people are putting oxybenzone in the environment. Well, we said success. We found that titanium dioxide because here's our background site, our upstream site, and the same pattern emerges that during the time that people are in the river, we see higher titanium than these nighttime hours. But we did some calculations and there was a problem. If you look, we are talking about nanograms per liter here, and here we're talking about micrograms, 1,000 times more. That was just too much titanium to explain. So let's look a little closer. And what we also saw was that things like aluminum and iron would also show these patterns during the day and night. Well, if you start thinking about aluminum, iron, titanium, other of those elements, those are the components of the earth, the things that make up soils and sediments. So our alternative hypothesis is, although we believe the bathers are putting oxybenzone into the water through their sunscreens, we think the bathers are putting the titanium and these other elements in through either stirring up the sediments or eroding the bank as they enter and leave the stream. I think anyone who's watched these activities in Golden don't think that's much of a stretch to think that erosion might be happening. So the consequences, if we're looking to see if any of that titanium is coming from sunscreen, we have that problem that we have the background to deal with. Kind of running out of time, so I might just hit one last highlight and then leave time for questions. But this is my kind of summary slide that, in many cases, nature is producing something. It's not producing oxybenzone, so that made it kind of easy for us to see. But if we're worried about other kinds of particles that might be coming from nature or coming from us, if there's a natural source as well, then our final exposure levels, the things we get exposed to, are a mixture of both nature and human activity. So we have to try to extract those two from one another. So we're kind of looking for that needle in the haystack. We're trying to find these human-introduced particles in the presence of all the background particles. So what do we find? Recreational use in Clear Creek and Golden, we definitely are introducing chemical sunscreens into water. There's some type of erosion or sediment disturbance by all this activities. We didn't see much zinc, but the issue is that we still have a little bit of zinc coming from the old mines upstream. So our background for zinc is higher. And we didn't do it, there's a million chemicals we could search for. We had to do sort of a targeted analysis to ask the question, is this specific compound there? But we did look at nutrients, and we didn't see any changes in nitrogen or phosphorus. Pretty much focused on again, this resuspension of sediments and the sunscreens. So I just want to kind of maybe wrap it up here and to leave time for questions, but presence doesn't necessarily imply risk. More knowledge about hazard is needed. If you look at risk, we know that risk is a product of hazard exposure. So the first thing we did was, yes, the environment is being exposed to oxybenzone, but at the levels we see, is there a hazard or not? That's not a question that my research answers. My research and that of my students is all geared toward trying to determine the exposure in pretty complicated systems. I already pointed out the problem of background particles. So let me skip these other studies and just go to the acknowledgements. So this particular research was done over several years. So Rob Reed finished his PhD degree a few years ago and is now at Post Nova, a company that builds equipment for some of these kinds of studies. Dr. Logan Rand is now at Arizona State University doing a postdoc. Evan Lloyd will be finishing up his master's very soon, we hope. And Sean Peavers is a new student who's just been with me for a year and has been working on the urban issues related to Clear Creek in where it enters the South Platte. I think I should stop there and just see if I've generated any questions or not. And I, again, thank you for your time and attention.
Wonderful. Thank you, Jim. If you have any questions, use the mute/unmute button in the bottom left-hand corner of your screen and feel free to dive in.
Yes, first, thanks for the presentation. Very interesting. Can you give us any insight into what's going on in the way of continuing reclamation or issues with respect to the runoff from the old gold and silver mines upstream?
I can give you one example. One example. I was concerned about time, but there's been a few remediation activities. The Argo Tunnel in Idaho Springs was treated a number of years ago, and more recently, the North Clear Creek plant just east of Blackhawk. You'll see it when you're driving to town, has gone online, and so we've been examining the chemistry of the water, and we have colleagues up at CSU that have been counting the critters. Again, this is just one case study, so I can't speak to all the activities. But what I wanted to show was when the plant went online in 2017, there was a pretty immediate visual transformation of the stream. Oh, I'm sorry. Am I still sharing? You can see that slide?
You are.
Yes.
Yeah, we can see it.
Okay. Sorry. I thought I might have stopped sharing. There was an immediate visual improvement within a short period of time. We were able to look at a long-term data set that's actually, we got from the city of Thornton, actually, because they're concerned about their water quality. This is the amount of iron present from 1994 to 2014. And then this is after the plant. Again, it's a log scale. So this is a big drop. This is like a 100-fold drop. So you can see that they've done a great job of treating North Fork. And we see similar kinds of things in copper and zinc as well. And so this particular treatment plant seems to be pretty effective. There's still some sources that we still see. It's not pristine by any means, but there's been some big improvements. I think Kathy might be able to actually jump in to talk about the broader picture of what's been going on in Colorado, because as part of her time at USGS, they were involved in another number of studies looking throughout Colorado at mining impacted streams.
Great, thank you very much.
Hi, I have a question about the toxicity, and I know your study didn't really go into the toxicity, but do you then share your results? Like, and where I'm coming from is like in California, they absolutely ban certain types of sunscreen, and it has something to do with the coral reefs and, I don't know, lack of oxygen in the water. Do you, are you noticing any problems? And then the stream obviously goes really far. Does it go into Denver? And are there any fish with like one eye or 9 inches or something like that?
Yeah.
What have you found?
Yeah, so again, this is a pretty limited study. So we do toxicology in my lab. Mostly it's about metal toxicology under kind of laboratory conditions. And so we didn't apply any of that to this. Again, as I mentioned, we were really looking at the exposure part. We're sampling more downstream now, but for the moment, our sunscreen data only is for golden itself. So presumably, these chemicals do not break down rapidly. Eventually, oxybenzone does break down. So we would assume that it would continue to persist downstream. I know no studies on fish effects. I do know that most times when I've seen laboratory studies, there's definitely a link to the coral issue, but I have not seen any studies that have really shown, there have been effects shown in the laboratory, but oftentimes, those concentrations are pretty high. So I'm kind of struggling to say, no, I don't know the answer to your question. We don't believe we're seeing any effects on the aquatic ecosystem, but it's not been studied.
Okay, thank you.
Do we have any more questions today?
Yes, one more question, and it's not directly related to the sunscreen study, but do you know, is there a substantially different water quality level in Golden versus, say, going up to Georgetown or one of the more upstream locations?
I think the state of Colorado has a lot of data on that. You know, there's been monitoring of Clear Creek for a long time. Partly, I think some of the monitoring was to follow whether some of these remediation activities that occurred, like in Idaho Springs, were successful or not. I do know that also, as I mentioned before, Stanley Lake gets their water from Clear Creek, so they're very concerned about things like phosphorus and nitrate. And so I think there is, without getting myself too far out there, I do believe there's, as any case, as you go from the headwaters to Golden, there are wastewater treatment plants at various places. So in general, I would assume the water quality is degrading a little bit as you go downstream. But again, there's been a lot of attempts at mitigating various things. And again, especially since, the city of Thornton is really concerned about, or is it Westminster? Sorry, what's going into Stanley Reservoir. So there's plenty of data. I would suggest, again, going to the CDPHE websites, and you can probably find a lot of that information there.
Wonderful. Thank you so much, Jim. If you have any more questions, this is your last chance because we're going to go ahead and wrap up. I want to say first, thank you so much to Jim today. What a wonderful presentation. And also thank you to Kathy for spearheading this. Again, if you missed part of the presentation or if you want to share it with friends or family, go to goldenunited.org and you'll find the link to our YouTube channel where you can find all of our virtually golden presentations available there. Kathy, do you want to talk about who's coming up next in our presentation schedule?
Sure. Thanks, Annie. And thank you, Jim, for a great presentation. Next week, Donna Anderson will be back telling us about how geology shapes the Golden landscape. And on Thursday, Stacy Fowler is going to take us on a tour of parts of Golden downtown in the historic district and along the creek. And our last talk will be on Cinco de Mayo, May 5th. Paul Hazeman and Bill Roby have prepared a talk about Golden railroads. So something to look forward to in the next couple of weeks.
Wonderful. Thank you so much, Kathy. And thank you everybody for joining us today. We'll be back next week on Tuesday, same time, same place. See you then. Thank you.